strategies when the number of output classes is greater than when there are two main possibilities to manage a classification problem. When the output classes is greater than 1, then there are two possible ways to manage this classification problem, that is 1 versus all or 1 versus 1. We already see the classification. What is classification? Classification means what? We are giving the class label to the data, right? So when there are more than one class label is available, then this strategies is useful to manage that classification problem, right? So in both cases the choice is transparent and the output written to the user will always be the final value or class. However, it's important to understand the different dynamics in order to optimize the model and to always pick the best alternative. In both the cases, choice is transparent, and whatever the output is taken, that is the final in both the cases. But what are the different strategies used by these two different models that we have to see, and whichever the best suited for our example, that we have to pick, right? So that's why we will see one by one how it works. So first one is the one versus all. So how it works? So this is probably the most common strategy and is widely adopted by scikit-learn for most of its algorithms. This is the most common strategy used by the scikit-learn for most of its algorithm. Now what is this scikit-learn? So this is one of the we can say header file or the class which is used by the Python to implement the different algorithms in Python, or we can say different classification algorithms in the Python. So whatever the algorithms used by the Python using the scikit-learn, so this is the one of the most common strategy used by them. So if there are n output, now we'll see how it works. Okay, so if there are n output classes and n classifiers will be trained in parallel, considering there is always a separation between an actual class and the remaining ones. If we are having n output classes, so parallelly this n classes will be classified using the n classifier. Okay, and the separation between an actual class and the remaining class is observed. And this is or we can say this, if there are n output classes available, then parallelly n different classes will be trained parallelly, and the actual class will be obtained from that, and that will be identified from the remaining ones. So this approach is relatively lightweight. At most n-1 checks are needed to find the right class, so it has an big O of n complexity, and for this reason it's normally the default choice and there is no need for further actions. Clear? So this is the default choice, we can say, and there is no need for the other strategy. Now how it works actually? So it is used by the scikit-learn for most of the algorithms. How? Because here if we consider the n output classes, then we require the n classifiers, and these n classifiers will classifies that n different classes parallelly, and it will find out the final actual class. So that's why it is the most default choice to choose. Now what happened in 1 versus 1 then? The alternative to 1 versus 1 all is training the model for each pair of classes. We have to train the model for each pair of classes at very different time. We cannot train it for parallelly. We have to train one by one after another, we can say. So the complexity is no longer linearly, it's big O of n square, because how many classes are there, that many times we have to train that particular class, that's why. And the right class is determined by a majority vote. In general, this choice is more expensive and should be adopted only when a full dataset comparison is not preferable. Clear? So this is all about the multi-class strategies. Now next point is